Hello everyone, Dennis here. In this video, I'm going to discuss with you GC O-Level Physics October-November 2024 paper 1. Subject code is 6091. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 1. Which expression contains only SI-based units? A. kg meter square per second square coulomb. B. kg meter square per second cube ampere. C. joules per ampere second. D. Newton meter per ampere second. The answer is B. kg meter square per second cube ampere. Now, let's recall the base quantities and SI units. There are 7 base quantities. Number 1, length. SI unit is meter, symbol M. Number 2, mass. SI unit is kilogram, symbol kg. Number 3, time. SI unit second and the symbol is S. Number 4, electric current. SI unit is ampere and symbol is A. Number 5, temperature. SI unit is Kelvin and symbol is K. Number 6, amount of substance. SI unit mole and symbol mole. Number 7, luminous intensity. SI unit is candela and symbol CD. From these 4 options, option A, C is coulomb, which is used to measure electric charge. For C, joules, which is used to measure energy. And for D, Newton is used to measure force. These units are not the base quantities. Hence, the answer is B, kg meter square per second cube ampere. Question 2. A force of 3 newtons and a force of 4 newtons act at an angle theta degrees to each other on the same object. The angle theta can vary from 0 degrees to 90 degrees. What is not a possible magnitude of the resultant force? A. 1 newton, B. 5 newtons, C. 6 newtons, or D. 7 newtons. The answer is A. 1 newton. To obtain the answer, we need to test the lower limit and the upper limit. First, the lower limit when theta equals to 0 degrees, both the 3 newtons and 4 newtons are parallel to each other. Therefore, the resultant force is the sum of these two forces and we'll get 7 newtons. Then, we test the upper limit when theta equals to 90 degrees. We can draw a tip-to-tail diagram to determine the resultant force, and this is the resultant force. To determine the magnitude of the resultant force, we can apply Pythagoras theorem, which is square root of 3 square plus 4 square and is equals to 5 newtons. Hence, the range of the resultant force F will be from 5 newtons to 7 newtons. And answer A, 1 newton, is out of this range. Question 3. A metal rod of length 3 meters is hit at one end with a hammer. The time taken for the sound to reach the other end of the rod is measured 4 times. The measurements are 0.56 milliseconds, 0.62 milliseconds, 0.64 milliseconds, and 0.58 milliseconds. What is the average speed of the sound in the rod? A. 1250 meters per second. B. 2500 meters per second. C. 5000 meters per second. Or D. 10,000 meters per second. The answer is C, 5000 meters per second. To calculate the average speed, first we need to determine the average time. We will add all the measurements together and divide by 4 and we'll get 0.6 milliseconds. Now to calculate average speed, it will be the distance traveled by the sound, which is the length of the rod, 3 meters, divided by the average time, 0.6 times 10 to the power of negative 3, and we'll get 5000 meters per second. Hence, the answer is C, 5000 meters per second. Question 4. Which equation defines gravitational field strength? A. Gravitational field strength equals gravitational force times its mass. B. Gravitational field strength equals gravitational force divided by mass. C. Gravitational field strength equals gravitational force divided by weight. Or D. Gravitational field strength equals weight divided by gravitational force. The answer is B. Gravitational field strength equals gravitational force divided by mass. So, recall the definition of gravitational field strength, which is the gravitational force per unit mass experienced by a mass at a specific point in a gravitational field. It is a measure of how strong the gravitational field is at that location. Hence, the answer is B. Gravitational field strength equals gravitational force divided by mass. Question 5. A piece of metal is suspended at rest from a spring. What is the name of the force pulling the piece of metal downwards? A. Friction, B. Mass, C. Tension, or D. Weight. The answer is D. Weight. Remember the definition of weight, which is the force exerted on an object due to gravity. It is the measure of how strongly gravity pulls on an object with mass downwards towards the center of the earth. Hence, the answer is D. Weight. Question 6. A ball is moving downwards with an initial velocity that is greater than its terminal velocity in air. What happens to the ball? A. It begins to slow down. B. It continues to descend at its initial velocity. C. The terminal velocity of the ball increases. D. It has an acceleration that is equal to the acceleration of free fall. The answer is A. It begins to slow down. So this is a free fall concept where a ball falls down at initial velocity. As it falls down, it experiences air resistance until it reaches the terminal velocity. The initial velocity is greater than the terminal velocity, which means that it has negative acceleration, or it decelerates, which means that the ball slows down. Hence, the answer is A. It begins to slow down. Question 7. A car is accelerating along a level road. Only the front wheels of the car are driven by the engine. Which diagram shows the direction of frictional force F1 on the front wheels and the direction of frictional force F2 on the rear wheels? So this is option A, option B, option C, and option D. The answer is B. To understand how it works, you need to know two forces. The first force is driving force Fd. So a driving force is a force that causes or initiates motion, or a change in motion of an object. The second force that you need to know is the frictional force, Fr, which is a force that opposes motion between two surfaces in contact. Frictional force is always in the opposite direction of driving force. Now, let's look at the front wheel. As described by the question, it is attached to the engine. When the engine rotates the rod that connects between the front wheel and the engine, the front wheel will rotate in this direction as well. Hence, it applies the driving force to the floor in this direction. Hence, the frictional force which opposes the driving force will react in this direction. On the other hand, the rear wheel is dragged to the front by the engine. The driving force of the rear wheel will be the same direction of the force that drags the rear wheel. The frictional force will react in the opposite direction of the driving force, hence it will be in this direction. Therefore, the answer is B. Question 8. The diagram shows a vertical force F acting on a wheelbarrow of weight 400 newtons. The center of gravity of the wheelbarrow is 0.80 meters from the axle of the wheel. What is the minimum value of F needed to lift the support off the ground? A. 200 newtons, B. 320 newtons, C. 400 newtons, or D. 800 newtons. The answer is A. 200 newtons. So to determine the answer, first we need to determine the pivot. So here is the pivot. Based on the principle of moment, the sum of anti-clockwise moment will be equals to the sum of the clockwise moment. So this diagram shows that there are two forces that causes the moment. The 400 newtons moment will cause an anti-clockwise moment. So the moment can be calculated as 400 newtons multiplied with the perpendicular distance between the force and the pivot. So for this case, it's 0.8 meters. Then for the clockwise moment, it is caused by the force F, which lifts the wheelbarrow. So it will create a clockwise moment, and this moment can be calculated as the force F multiplied with the distance between the force and the pivot, so which is 0.8 meters plus with 0.8 meters. Then the force will be equals to 400 times 0.8 divided by 1.6, and we'll get 200 newtons. Question 9. The diagram shows a glass vase for flowers. The vase is a rectangular block of glass with a cylindrical hole. The dimensions of the rectangular block are height 10 cm, width 9 cm, depth 5 cm. The dimensions of the cylindrical hole are height 7 cm, diameter 3 cm. The vase has a mass of 1 kg. What is the density of the glass? A. 2.2 grams per centimeters cube, B. 2.3 grams per centimeters cube, C. 2.5 grams per centimeters cube, or D. 2.6 grams per centimeters cube. The answer is C. 2.5 grams per centimeters cube. So before we're going to calculate the density of the glass, first we need to know the volume of the vase, which is the volume of the block minus the volume of the cylinder. So the volume of the block will be 10 times 9 times 5, then minus the volume of the cylinder, which is pi r square h, or pi times 3/2 square times 7, and we'll get 400 centimeters cube. So we know the formula for density rho equals to the mass m divided by the volume v. We substitute the values, the mass 1 kg or 1000 grams divided by the volume of the vase, which is 400 centimeters cube, and we will get 2.5 grams per centimeters cube. Question 10. Given this diagram, X, Y, and Z are glass vessels containing water. They are on the same horizontal table, and the water is at the same level in each of them. Px, Py, and Pz are the pressures in the water at the bottom of X, Y, and Z respectively. Which relationship is correct? A. Px equals Py equals Pz. B. Py is greater than Px is greater than Pz. C. Py equals to Px and Px is greater than Pz. Or D. Pz is greater than Py is greater than Px. The answer is A. Px is equals to Py equals to Pz. Now we know that the formula of pressure of liquid is equals to rho GH. So rho is the density of the liquid, G is the gravitational field strength. So these two are constant, hence it is determined by the H. So for these three containers, they have the same height. Hence, the pressures of X, Y, and Z are equal because they have the same height. The answer is A. Question 11. A manometer containing water is used to measure the pressure of a laboratory gas supply. The water in the manometer is stationary. Which statement is correct? A. The pressure of the gas supply is equal to the atmospheric pressure. B. The pressure of gas supply is greater than the atmospheric pressure. C. The pressure of gas supply is less than the atmospheric pressure but greater than 0. D. The pressure of gas supply is equal to 0. The answer is B. The pressure of gas supply is greater than the atmospheric pressure. We know that the pressures at the same level are equal. So let's label the pressure at this point as P1 and the pressure at this point as P2. Hence, P1 equals to P2. The pressure at P1 comes from the pressure of gas supply. So let's label it as P gas. For pressure number 2, P2, the pressure comes from the atmospheric pressure, P atm, and the pressure of the water, P water. Hence, as you can see, this equation, P gas equals to P atmospheric plus P water. Therefore, we can make a conclusion that the pressure of gas supply is greater than the atmospheric pressure. Question 12. What is not an example of a potential energy store? A. Chemical, B. Elastic, C. Gravitational, or D. Kinetic? The answer is D. Kinetic. Chemical energy is the energy stored in food, battery, or etc. For elastic energy, it is energy stored in stretched rubber band, stretched or compressed spring. Gravitational potential energy is the energy stored due to the height or the position of an object. The formula of gravitational potential energy Gp is equals to mgh. For kinetic energy, it is the energy due to movement or motion of an object. So the formula for kinetic energy is half mv squared. Question 13. A 5.0 kilowatt electric heater is used for 2 hours. How much energy is transferred electrically to the heater? A. 1.0 times 10 to the power 4 joules. B. 3.6 times 10 to the power 4 joules. C. 6.0 times 10 to the power 5 joules. Or D. 3.6 times 10 to the power 7 joules. The answer is D, 3.6 times 10 to the power of 7 joules. So to calculate the energy transferred, we can use the formula E equals to PT. P is for the power and T is for the time. So the power of the electric heater is 5.0 times 10 to the power of 3. The time is 2 hours. We need to convert this into seconds. Hence, we multiply with 60 and 60. So the answer will be 3.6 times 10 to the power of 7 joules. Question 14. A gas is trapped in a sealed container. The volume of the container is kept constant as the gas is heated. What happens to the gas particles? A. They collide with the container walls less frequently. B. They expand. C. They get further apart. D. They move more quickly. The answer is D. They move more quickly. Since the gas is heated, which means gas particles receive more energy. The speed of motion of the particle increases. Therefore, they move more quickly. Question 15. Thermal conduction is a method of energy transfer in solid rubber. In which direction is energy transferred and how does conduction occur? So here are a few options. Option A, the direction of energy transfer is from region of high temperature to region of low temperature. And how conduction occurs in solid rubber is by electron movement. Option B, the direction of energy transfer is from region of high temperature to region of low temperature. And how conduction occurs in solid rubber is by molecular movement. Option C, the direction of energy transfer is from region of low temperature to region of high temperature. How conduction occurs in solid rubber is by electron movement. Or option D, the direction of energy transfer is from region of low temperature to region of high temperature, and how conduction occurs in solid rubber is by molecular movement. The answer is B. The direction of energy transfer is from region of high temperature to region of low temperature, and how conduction occurs in solid rubber is by molecular movement. So, high temperature means it has high thermal energy, while low temperature means the region has low thermal energy. So, thermal energy transfer happens from the region with high thermal energy to the region with low thermal energy. So this is a solid rubber and it is non-metal, which means that it does not have free electrons. Hence, conduction occurs in solid rubber is by molecular movement, which has slower heat transfer rate. Hence, solid rubber is a good insulator. Question 16. A student has 4 cubes of equal dimensions, each made of the same material. The surfaces of the cubes have different colors and textures. The cubes are initially at a temperature of 80 degrees Celsius and are left to cool in a room temperature at 20 degrees Celsius. Which cubes experiences the smallest initial rate of decrease in temperature? Option A, black color and dull texture. Option B, black color and shiny texture. Option C, white color and dull texture. Or option D, white color and shiny texture. Answer is D, white color and shiny texture. Remember that white and shiny surfaces are poor emitter and absorber, especially by radiation. Hence, the answer is D, white color and shiny textures. Question 17. A cup has a mass of 0.30 kg when empty and a mass of 0.50 kg when filled with water. The heat capacity of the cup is 200 joules per degree Celsius, and a specific heat capacity of water is 4200 joules per kg degree Celsius. How much energy heat is needed to raise the temperature of the cup and water by 60 degrees Celsius? A. 54,000 joules, B. 62,000 joules, C. 130,000 joules, or D. 140,000 joules. The answer is B. 62,000 joules. To answer this question, we need to use two formulas. The first formula is the heat capacity of the cup. Q cup equals to C delta theta, where Q cup is the amount of heat needed to change the temperature of the cup, C is the heat capacity of the cup, and delta theta is the change of the temperature. So given that the C is 200 and the change of temperature is 60 degrees Celsius, then we get the heat needed to change the temperature of the cup is 12,000 joules. Now the second formula that we need to use is the specific heat capacity formula. So Q water equals to mc delta theta. Q water is the heat needed to change the temperature of the water by 1 degree Celsius. It is equals to the mass of the water, m, the specific heat capacity of the water, C, and the delta theta is the change of the temperature. Given the mass, we need to calculate which is the mass of the cup with water is 0.50, then minus the mass of the cup when it is empty. We'll get the mass of the water, then multiply with the specific heat capacity of the water, which is 4,200 joules per kg degree Celsius, and the change of temperature is 60. Hence, we'll get 50,400 joules. So adding these two energy together, so the total heat needed is 12,000 plus 50,400. We'll get 62,400 joules. Question 18. A sample of warm liquid has a mass of 50 grams. Energy is extracted from the liquid at a steady rate of 200 watts. A student records the temperature of the sample at regular time intervals. The graph shows her results. So here is the graph. What is the specific latent heat of fusion of the sample? A. 0.040 joules per gram, B. 8.0 joules per gram, C. 60 joules per gram, or D. 400 joules per gram. The answer is D. 400 joules per gram. So we want to calculate the specific latent heat of fusion. Then we need to look at this region. So the time for this region is 100 seconds. So how to get this value? If you 150 minus 50, that's where you get 100 seconds. Now applying the specific latent heat of fusion formula, Q equals to mLF. The Q is the power times the time. So PT equals to mLF. They will substitute the values given the power is 200 watts and the time is 100 seconds. So equals to the mass of the liquid is 50 grams and multiply with LF. Hence, the specific latent heat of fusion LF will be equals to 200 times 100 over 50 and we'll get 400 joules per gram. Question 19. Which types of waves can be seen using vibrations in stretched strings and waves on the surface of a ripple tank? So here are the options. Option A, vibrations in springs are longitudinal only, while the waves on surface of a ripple tank are transverse only. Option B, vibrations in springs are longitudinal only. Waves on surface of a ripple tank are both transverse and longitudinal. Option C, vibrations in springs are transverse and longitudinal, while the waves on surface of a ripple tank are transverse only. Or option D, the vibrations in springs are transverse and longitudinal, while the waves on surface of a ripple tank are transverse and longitudinal. The answer is C. The vibrations in springs are transverse and longitudinal, while the waves on surface of a ripple tank are transverse only. Okay, so remember the vibration in spring, we can produce both transverse waves and longitudinal waves, while the surface of a ripple tank, we only can produce transverse waves. Question 20. Given this diagram, a ray of light is incident on the boundary between two mediums. Some of the light is refracted and some is reflected. What is the same for the incident and refracted rays? A. Brightness, B. Frequency, C. Speed, or D. Wavelength. The answer is B. Frequency. So based on the wavelength formula, V equals to F lambda, which means that the speed is proportional to the wave lambda. So when a wave or the ray of light is traveling from one medium to another medium, then the speed will change. So if it is from the optically less dense medium to optically denser medium, then the speed will reduce. So if the speed change, then the wavelength lambda will change as well. Therefore, option C and option D are incorrect. Where for option A, brightness, as you can see, some incident rays is refracted and some is reflected. Hence, the brightness of incident ray will be greater than the brightness of the refracted ray. They cannot be the same. Therefore, there is only one answer, which is B, frequency. Question 21. Which statement about waves is correct? A. All transverse waves travel at the same speed. B. There are no waves that can travel in a vacuum. C. There are some longitudinal waves that can travel in a vacuum. Or D. The particles in a longitudinal wave vibrate in the direction of energy transfer. The answer is D. The particles in a longitudinal wave vibrate in the direction of energy transfer. For option A, as mentioned in question 20, the formula for wave V equals to F lambda, as you can see that the speed of the waves is determined by the frequency and the wavelength lambda. Hence, not all transverse waves travel at the same speed. It depends on the frequency and the wavelength. For option B, there are no waves that can travel in a vacuum, so this statement is not correct because transverse waves can travel in a vacuum. Option C, also incorrect. There are some longitudinal waves that can travel in a vacuum because all longitudinal waves cannot travel in a vacuum. They require medium to travel. Hence, there is only one statement is correct, which is option D. The particles in the longitudinal wave vibrate in a direction of energy transfer. Question 22. A loudspeaker produces a sound that is too loud. The loudspeaker is adjusted so that it produces a quieter sound of the same pitch. What happens to the amplitude and frequency of the sound as the loudspeaker is adjusted? Option A. Amplitude becomes greater, while frequency stays the same. Option B. Amplitude becomes smaller, while frequency stays the same. Option C. Amplitude stays the same, while frequency becomes smaller. Option D. Amplitude stays the same, while frequency becomes greater. The answer is option B. Amplitude becomes smaller while frequency stays the same. So remember that amplitude can determine the loudness of the sound wave, while frequency we determine the pitch of the sound wave. So the question says that the loudspeaker is adjusted so that it produces a quieter sound of the same pitch. So the keyword quieter means amplitude becomes smaller, while the keyword same pitch means the frequency stays the same. Question 23. Which row is correct for X-ray? A. It is a longitudinal wave. The use of X-rays is in medical radiology. Option B. It is a longitudinal wave and the use is on television remote controller. Option C. It is a transverse wave and the use of X-rays is on medical radiology. Option D. It is a transverse wave and the use of X-rays is on television remote controller. The answer is C. It is a transverse wave and the use of X-rays is on medical radiology. So remember, X-ray is in electromagnetic spectrum, which is a transverse wave, and the use is on medical radiology. For television remote controller, we use infrared. Hence, the answer is C, transverse wave, and use is on medical radiology. Question 24. A smooth silver ball acts as a mirror and reflects light. The diagram shows a ray incident on the surface of the ball. Which row is correct? First statement, PQ is the normal for this ray. Second statement, the angle of incidence is 50 degrees. Option A, first statement is false, second statement is false. Option B, first statement is false, second statement is true. Option C, first statement is true, second statement is false. Option D, first statement is true, second statement is true. The answer is B. First statement is false and second statement is true. So as you can see, PQ is not the normal of the ray, but it is the tangent of the surface. Now, how to determine the angle of incidence? So this is the angle of incidence, and the tangent is perpendicular to the normal. Hence, the angle of incidence will be 90 degrees minus 40 degrees, which gives us 50 degrees. Therefore, answer is B. PQ is the normal for this ray, is false. The angle of incidence is 50 degrees, is true. Question 25. Given this diagram, a ray of light passes from ice into air. The angle between the ray and the boundary is 50 degrees. The refractive index of the ice is 1.3. What is the angle of refraction of the light in air? A. 30 degrees, B. 36 degrees, C. 57 degrees, or D. 85 degrees. The answer is C. 57 degrees. So for this case, the light travels from ice into the air, which means that it travels from optically denser medium to less denser medium. According to Snell's law, n equals to sin I over sin r, where n is the refractive index, I is the angle of incidence, and r is the angle of refraction. However, this formula applies to the case where the light travels from optically less denser medium to denser medium. According to the principle of reversibility, a ray of light will take the same path if its direction of travel is reversed. Therefore, for our case, since the ray of light travels from optically denser medium to less denser medium, then we can treat the angle of incidence as the angle of refraction and the angle of refraction as the angle of incidence. So this is the normal, which is perpendicular to the boundary, and this is the angle of refraction Alright, remember as I said, we are reversing the path, hence this is the angle of refraction. We can obtain the values by taking 90 degrees minus 50 degrees, which gives us 40 degrees. Next, this angle will be the angle of incidence. And now we want to find this angle. So, using the Snell's law, the refractive index is given as 1.3, which is equals to sine I over sine 40 degrees. Then we calculate sine I equals to 1.3 sine 40 degrees. I will be inverse of sine 1.3 times sine 40 degrees, which is 56.7 degrees. Hence, the closest answer will be C, 57 degrees. Question 26. Given this diagram, the diagram shows a thin converging lens. The point labeled F is a distance from the lens that is equal to the focal length of the lens. The point labeled 2F is a distance from the lens that is twice the focal length of the lens. An object placed at point P forms an enlarged virtual image. Where is P? A. Between the lens and F. B. Between F and 2F. C. At 2F. Or D. Further away from the lens than 2F. The answer is A. Between the lens and F. Now let's complete the ray diagram to prove the answer. So this is the object that is placed between the lens and F. This is the focal point and at the other side of the lens. So first we draw a ray which is parallel to the principal axis. After passing through the lens, it will bend towards the focal point. Another ray passes through the center of the lens and will continue to travel on a straight line without being refracted. Now, we extend these two rays at the back of the lens and they intersect at one point. At this point, we can draw the image of the object. Hence, we find that this image is enlarged, virtual, and upright. Therefore, the answer is A. P is between the lens and F. Question 27. The electric field between two oppositely charged plates is shown. An oil drop is placed between the plates and it moves vertically upwards towards the top of the page. Which property does the oil drop have? A. It acts as a magnetic north pole. B. It acts as a magnetic south pole. C. It has a positive charge. Or D. It has a negative charge. The answer is D. It has a negative charge. Electric field points from positive terminal to negative terminal. Hence, the charge plate at the top is positive and the charge plate at the bottom is negative. The oil drop moves vertically upwards towards the top of the page, and we know that unlike charges attract, like charges repel. Hence, the oil drop has a negative charge as it is attracted to the positively charged plate at the top. Question 28. In some spray paint guns, particles of paint are given a positive charge as they leave the nozzle of the gun. The gun is placed close to the object to be painted. Why is the object earthed? A. So that the operator of the gun does not receive an electric shock. B. So that the positive charge from the paint flows to earth. C. To attract the particles of paint to the object. Or D. To repel the paint droplets so that they spread out. The answer is C. To attract the particles of paint to the object. So this is the spray paint guns. And this is the object to be painted and it is earthed. When the paints are sprayed out from the nozzle of the gun, they are positively charged. So these charges attract electrons from the earth to flow onto the surface of the object to be painted, and it becomes negatively charged. And the positively charged paint particles are attracted at the surface of the object, and they are evenly attached to the surface of the object. Hence, the answer is C, to attract the particles of paint to the object. Question 29. A battery is connected to two parallel resistors. The resistance of one resistor is 5.0 ohms and the resistance of the other is 10 ohms. The current in the 10 ohm resistor is 0.20 ampere. How much charge flows through the battery in 20 seconds? A. 0.030 coulomb, B. 4.0 coulomb, C. 6.0 coulomb, or D. 12 coulomb. The answer is D. 12 coulomb. So this is the voltage across the battery, and V1 is the potential difference across the 10 ohm resistor. According to Ohm's law, V equals to IR, and from the diagram we can see that the 10 ohm resistor is connected parallel to the battery, hence V battery is equals to V1, and V1 can be calculated as the current multiplied with the resistor, which is 0.2 times 10, and we'll get 2 volts. So the voltage of the battery is also 2 volts. Next, the 10 ohm resistor and the 5 ohm resistor are connected parallel. So we can calculate the equivalent resistance with the formula 1 over R equivalent equals to 1 over 10 plus 1 over 5. We get 3 over 10. Hence, the equivalent resistance is 10 over 3 ohms. So this is the current flows out from the battery, and we can calculate it with the formula I equals to V battery over R equivalent. Then we substitute the values. V battery is 2 and the R equivalent is 10 over 3. Hence we get the current is 0.6 amps. To calculate how much charge flows through the battery in 20 seconds, we use this formula Q equals to IT. The current is 0.6 and the time is 20 seconds. We'll get 12 coulomb. Hence the answer is D, 12 coulomb. Question 30. A circuit consists of a cell and two resistors connected in series. What is equal to the work done by the cell when it drives unit charge around the complete circuit? A. The current in the circuit. B. The electromotive force EMF of the cell. C. The potential difference PD across each of the resistors. Or D. The power supplied by the cell to the resistors. The answer is B. The electromotive force EMF of the cell. So the statement in the question is the definition of EMF, which is the electrical energy provided to a circuit by a source, example a battery or generator, to drive one unit of electric charge around the complete circuit. Hence, the answer is B, electromotive force EMF of the cell. Question 31. Given this diagram, a power supply of constant electromotive force EMF is connected to a switch, a fixed resistor, and a piece of metal wire. When the current is switched on, the temperature of the wire begins to increase. What happens to the current in a circuit and to the potential difference PD across the wire as the temperature of the wire increases? Option A. Current in circuit decreases, PD across wire decreases. Option B. current in circuit stays the same, PD across wire decreases. Option C, current in circuit decreases, PD across wire increases. Or option D, current in circuit stays the same, PD across wire increases. The answer is C. Current in circuit decreases, PD across wire increases. So when the temperature increases, then the resistance of the wire increases. Hence, the current flows in the circuit decreases. On the other hand, when the resistance increases, the potential difference across the wire increases. This is because based on the potential divider formula, V2 equals to R2 over R1 plus R2 times if V in. So when the R2, which is the resistance of the wire, increases, then the V2, which is the potential difference across the wire, increases. Question 32. A student sets up the circuit shown. What is the current I1 and what is the potential difference V2? Option A, I1 is 0 amps, V2 is 4 volts. Option B, I1 is 0 amps, V2 is 8 volts. Option C, I1 is 4 amps, V2 is 4 volts. Option D, I1 is 4 amps, V2 is 8 volts. The answer is D. I1 is 4 amps and V2 is 8 volts. Okay, so let's talk about I1 first. First, the current flows up from the positive terminal of the battery and then pass through the first ammeter, which gives a reading of 4 amps. So which means that now the current is 4 amps. Then it continues to flow into the first lamp, then go to this node and branch up into two parts to flow into these two lamps, and then combines back together into one current and flows back to the negative terminal of the battery, and it passes through I1. So from here, as you can see, the current does not branch anymore. It will not flow into the first voltmeter V1 because voltmeter is internally open circuit. Hence, I1 will be 4 amps. Next, talk about the reading on V2. So as you can see, the lamps are connected in series. Okay, so as you can see from here, this lamp and these two lamps connected in parallel, so we can calculate their equivalent resistance. Then they are connected in series. So that's why V2 plus V3 will be equals to V1. Okay, so V3 is given 4 volts, V1 is 12, hence V2 will be 12 minus 4, which gives us 8 volts. Therefore, answer is D. I1 is 4 amps, V2 is 8 volts. Okay, next question, question 33. A 10 kilo ohms fixed resistor and a variable resistor are connected in series with a 12 volt battery as shown in this diagram. The resistance of the variable resistor can be varied between 0 and 5 kilo ohms. The potential difference across the variable resistor is Vout. What is the range of possible values for Vout? A. 0 to 4 volts, B. 0 to 8 volts, C. 4 to 8 volts, or D. 4 to 12 volts. The answer is A. 0 to 4 volts. So let's label the 10 kilo ohms fixed resistor as R1 and the variable resistor as R2. So using the potential divider formula, Vout equals to R2 over R1 plus R2 times V in. Now to calculate the range of Vout, first we choose the smallest value of the variable resistor, which is R2 equals to 0. Then, using this formula, we find that the Vout is equal to 0. Next, the largest value of the R2 is 5000 ohms. Then, using the formula to calculate the Vout, it will be 5000 over 10,000 plus 5000 times 12, and we get 4 volts. Hence, the range of possible values for the Vout will be from 0 to 4 volts. Question 34. A person replaces 4 60-watt filament lamps with 4 10-watt LED lamps. The lamps are used for 5 hours each day. How many kilowatt-hour of energy are saved each week by using the LED lamps instead of the filament lamps? A. 1, B. 7, C. 10, or D. 70? The answer is B. 7. So to calculate this value, first we find the power difference between the one filament lamp and the LED lamp. So the difference will be 60 minus 10, which gives us 50 watts. Then we can calculate the energy saved, which is 50 times 4 lamps, then multiply with 5 hours per day, and multiply with 1 week, which is 7 days. And we'll get 7000 watt-hour or 7 kilowatt-hour. Hence, the answer is B. Question 35. A heater has a switch and is connected to a fuse mains plug. In which circuit are the switch and fuse connected correctly? So here are the 4 options. Option A, B, C, or D. The answer is C. Okay, as you can see, both the fuse and switch are connected to the live wire. Now, why fuse is connected to live wire? So this is because when a fault occurs, such as overload or short circuit, the entire appliance is disconnected from the live power source. So this can prevent the dangerous flows of excessive current, protecting both the appliance and the user from potential damage or injury. On the other hand, switch is connected to live wire because this is to ensure safety. When the switch is turned off, it disconnects the appliance from the live wire. This can prevent any electrical potential difference from reaching the appliance and reducing the risk of electric shock. Question 36. The diagram shows a circuit. The switch is closed and iron nails are attracted to the metal bar inside the coil. When the switch is opened, the nails remain attracted to the lower end of the bar. What is the bar made from? A. Steel, B. Iron, C. Copper, or D. Aluminium? The answer is A. Steel. So as described by the question, when the switch is opened, the nails remain attracted to the lower end of the bar. So this means that the magnetic field retains even after the coil is disconnected from the battery. Hence, this can only be done if the metal bar is made from hard magnetic material. Therefore, the answer is A, steel, because steel is a hard magnetic material. Question 37. A small compass is placed close to a strong magnet on its middle line as shown. The Earth's magnetic field is negligible. In which direction does the compass needle point? So here are the 4 options. Option A, Option B, Option C, or Option D. The answer is D. So, When we know that the magnetic field will point out from the north pole of the magnet, and it can look back to the south pole. So the needle of the compass will point to the direction of the magnetic field. Hence, for this case, it will point to the right. Therefore, the answer is option D. Question 38. A current carrying wire ST lies between two magnetic poles P and Q as shown in this diagram. The wire experiences a force into the pitch. Which row gives the direction of the current in ST and identifies poles P and Q? Option A. Direction of current is from S to T. Pole P is north. Pole Q is south. Option B. Direction of current is from S to T. Pole P is south. Pole Q is north. Option C. Direction of current is from T to S. Pole P is north. Pole Q is south. Or option D. Direction of current is from T to S. Pole P is north. Pole Q is north. The answer is A. Direction of current is S to T. Pole P is north. Pole Q is south. Okay, so first, this case is current carrying wire case, and the wire experiences a force into the pitch, which means that electrical energy is converted to kinetic energy. Therefore, this is a motor case. So we need to use Fleming's left-hand rule. So this is Fleming's left-hand rule, where the index finger points from North Pole to South Pole. The middle finger points the direction of the current, and the thumb points the direction of the force. Then you need to move your left hand into this manner, and it will determine the direction of the current and also the pole P and pole Q. As you can see, the thumb is pointing onto the paper. You will see that index finger is pointing from P to Q, which means that P is north, Q is south. The middle finger will point the direction of the current, hence the current flows from S to T. Therefore, the answer is A. Question 39. Given these two graphs, graph 1 shows the electromotive force EMF produced by an alternating current AC generator. Which single change to the generator produces the output shown in graph 2? A. Increase the area of the coil. B. Increase the number of turns on the coil. C. Rotate the coil faster. Or D. Using a stronger magnet. The answer is C. Rotate the coil faster. So as you compare graph 1 and graph 2, graph 2 has greater amplitude and frequency compared to graph 1. So it has increased amplitude and increased frequency. A faster rotating coil will experience a greater rate of change of magnetic flux, leading to a higher induced voltage and increased amplitude. On the other hand, the frequency of the output voltage is directly proportional to the speed of rotation of the coil. Increasing the rotational speed of the coil will increase the frequency of the alternating current. Hence, the answer is C. Rotate the coil faster. Question 40. A human being absorbs two different types of electromagnetic radiation. Radiation 1 causes ionization in soft tissue. Radiation 2 increases the temperature of soft tissue. Which row could be correct? Option A. Radiation 1 is infrared. Radiation 2 is microwave. Option B, radiation 1 is infrared. Radiation 2 is gamma rays. Option C, radiation 1 is microwaves. Radiation 2 is infrared. Option D, radiation 1 is gamma rays and radiation 2 is infrared. The answer is D. Radiation 1 is gamma rays and radiation 2 is infrared. Okay, so this question is very straightforward and textbook based. So obviously gamma rays can cause ionization in the soft tissue and infrared can increase the temperature of soft tissue. So that's why if you feel hot, it is because there is an existence of infrared. Hence, answer is D. Radiation 1 is gamma rays and radiation 2 is infrared. Alright, that's the end of the paper and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Support me. If my videos benefit you in your learning, you can treat me a cup of coffee. To do this, link is at the description area. Until then, see you in the next video. Have a great day ahead and all the best.